Thank you, Renate. The floor is yours.
Thank you, Mike. So today I will present the soil improver applications that are possible, and one of the variants that we provided in the SASFIR project. So for this, first of all, we need to know what is a soil improver. And there is actually a definition in the European fertilizer regulation that states what soil improver is. This is in PHC 3. And there is a distinction between organic soil improvers and inorganic soil improvers. And for the organic soil improvers, the material has to consist 95% of solely biological origin. And it can be out of peat, leonardite, lignite, or it is not allowed to be of any other material that is fossilized or embedded in geological formations. And you have to have more than 20% dry matter. And of course, a very important point are the contaminants. You have to stick to certain limits that you can have, so you need a lot of the testing for your product. And then an inorganic soil improver, it's quite nice because it's any other soil improver that is not an organic soil improver. And of course, you have again the limitations on contaminants and heavy metals, copper, like this. So then all the definitions are quite nice. So, but what are actual soil improvers? And soil improver is an organic material substrate that improves the condition, fertility, and structure of the soil. And there are actually a lot of forms of soil improvers that are suitable for these applications. For example, some organic ones are, as you all know, a compost, but also tree bark, manure, seaweed, molasses, or worm casts. And for the inorganic ones, limestone, rock dust, gypsum, polysaccharides, and polyacrylamides. So, but what is now the difference between a soil improver, a fertilizer, and compost? How do we discern this? So this a soil improver versus a fertilizer. The soil improver can add macro and micronutrients via the organic matter. And it is improving the soil fertility, but also the structure. It can also be used to change the soil pH. And this is something we should keep in mind for later. And as a difference, inorganic fertilizers usually only provide the macronutrients, so N, P, and K, and sometimes also magnesium that are needed for plant growth, but usually they do not have a positive effect on the soil structure. And then soil improver versus compost. So actually compost is a soil improver because it will release macro and micronutrients over time. And also, in addition, you can add other soil improver ingredients to improve it further. And how do they work now? So a soil improver is destined or is meant to provide ideal conditions for the soil system to flourish and that the soil gets healthier. And this happens due to the symbiotic relationships between the root system and the fungi and also the other microorganisms like worms, nematodes, bacteria. So this is something very important. The soil improver should not interact negatively with this system. Also, a soil improver facilitates the easier absorption of macro and micronutrients. And if they contain biochar, perlite, or vermiculite, or other small stones, they actually usually help aerate the soil, again having an improved soil structure. And also, if they contain biochar or hydrogels, they can actually retain water, and this is very positive to decrease soil irrigation and plant irrigation. So now to some examples. One of the examples is agrobiochar, which is a novel soil improver. This is a lignin-based hydrogel, and it has the potential to reduce the soil water input and improve the irrigation efficiency. And agrobiogel has been registered as a soil conditioner in Austria already, and it also obtained an organic certification. And in addition, they have CO2 negative balance, and they are very environmentally friendly. And this is also an output that we will show during the SASFER project with the LCAs that will be provided. So what is now the soil improver we developed during the SASFER project? This soil improver is based on marine calcium carbonate granules, which were coated with lignosulfonates and probiotics. And there we did a lot of in vitro testing to actually ensure that the polymerized lignosulfonates that are used for this coating to be non-toxic to plants. You can see here the results of one of these trials where we can show that the germination is not negatively affected by the lignosulfonate. And also during the growth, you cannot see or measure any negative effects. If the lignosulfonate is applied to the system, just to explain it a little bit better, in this trial, you actually do not add the soil improver as a finished product, but you test the lignosulfonate coating in an excess amount on the plants to test if it's toxic to the plants. And then we added the probiotics, so microorganism strains that are known to help the plant root system take up nutrients and heighten the nutrient availability in the soil. So therefore we tested different strains, and this was done on lawn. And through measuring the lawn cuttings, we could show the increase of the plant growth and the yield on the lawn cuttings, especially with the strains AB53 and AB25. So therefore, we chose these two strains to go into further testing in field trials. And first we went into field trials, again in lawn, where we could show the effectiveness by seeing the better structure of the root system when the microorganism, the probiotic, is in the system. Also, the lawns are much stronger, and they can resist adverse weather conditions like droughts much better with the soil improver. In addition, we have the calcium carbonate in this soil improver. This means it has an effect on the soil pH, especially good for very acidic soils, which can be found in many regions in Europe, and which help improve the yields for other plants like potatoes, which we also did. Here I can show you some field trial results of the effectiveness of the soil improver in the potatoes, where we can see that we have overall higher yields and higher starch content in starch potatoes when the microorganisms are applied in the form of the soil improver. So here the soil improver acts together. This soil is very acidic, so we have the calcium carbonate base of the soil improver, and then the lignosulfonate coating, which has an effect on the release of the calcium carbonate, and then also the probiotics in the coating, which help the root structure to develop nicely. And this leads to higher yield and higher starch content. So if you want to know any more about the soil improvers we developed, don't hesitate to contact me.